My name is Andres Zepeda. I'm currently working as a DevOps engineer with Admios, and today I have the pleasure to introduce, and speak also about the introduction to microservices and container orchestration for this month Admios Learning Talk. So I will start right now, and if you guys have any questions, you can just ask them as in the moment, and also we will have a final section. We will be having a question and answer. Okay, so let's start. So the agenda for today is that we will start talking about microservice. What exactly are they? Then we will jump to the journey to cloud native. After that, we will be talking about containers, and then later on, we will be talking about the container orchestration itself. And later on, we will also be jumping to one of the most used and the de facto container orchestration as for the moment called Kubernetes. Then I will be doing a demonstration on the developing and deploying an LGS application to a Docker container and then deploying it directly to, you can say, a production environment on Google Kubernetes engine. And then we will have the questions and answer as well. So I would like to start the presentations with some, quotes from people. So this one is the one I kind of like, and is we cannot solve our problems with the same thinking we use when we created them, by a guy called Albert Einstein. So talking about microservices, there have always been this great gap between the developers and operations when there is a big wall of confusion between them when the developers are just sending and delivering the software updates or software itself to the operations teams, and they do not care once they develop and deploy actually develop and pass the program or the artifacts to the actual operations. They do not care about the actual end of their software. So that's something that is also introduced as a DevOps methodologies, and also a mindset that a lot of new companies are, well, not new companies, but a lot of companies are approaching. So this is also a typical image of, on the software developer life cycle, when you will have all the developers trying to push, the entire code, that in this case you can say that is that rock or that big black circle, kind of circle. And you will see people like, for example, this one, that is, you can say that that will be like the project manager, or yeah, the team leader that is trying to get the actual software like in order. And at the same time, you see that is adding like a weight to the actual to rock. You will also see like this person right here that is trying to push it in the other way around, because the actual direction is that this rock needs to go up, and this guy seems like he's trying to push it to the other way. And some people will call this guy like the operations team, the operations guy, the sysadmin, that is not trying to get new code. As you know, code can break things, and then production servers can like blow up. And also you will have this guy right here that some people call them like the DVAs. They are also the ones that are trying to leverage and move that rug to the other side. And once you realize, it's just the first sprint, you can say it. And those hills, you can represent them at the sprints, or the actual deployment timeline, on where you have to deliver the actual project, in this case project, not software nor service, the project itself. So we need to actually break that wall of confusion. Developers and operations need to work together, and they need to develop software like that, giving like in hand to hand, passing it through, since that's the actual mindset of working with DevOps, and moving to microservices. So that's basically like a big picture of what is like to be working right now on a lot of companies that are still doing that software in that way. I don't know if you guys have also experience working with those type of companies or enterprises. So the main goal at the very end is to have this thing, teamwork, delivering successful and rapid stones, circular stones, to the end of the hill. In this case, the sprint, you can call them. And that's what microservices itself are trying to achieve. So microservices definition, we can, in short, The microservice architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, often an HTTP resource API. These services are built around business capabilities and independently deployable by fully automated deployment machinery. So that's what microservices are, and is mostly defined as an architectural design, not like a software development style. But once you have the architecture of your microservices, you are able to start developing those microservices as you were just developing, your software itself. So I will be showing you some other pictures as well, so you can get the actual picture of why you should move to microservices. And also, there is something that is on the ecosystem as for right now, that microservices is not for everyone, but you should always try to enable them, and start developing microservices. So microservices at the end of the day is full about agility, and they improve your continuous delivery, your deployment, and improvement of the entire software developer life cycle, and therefore by using your pipelines to deliver the software in the best way you can to the end users. So this will be like the monolithic itself, your application, your current application that you currently have. You have your operating system, then you have your, in this case, a Java virtual machine if you're running Java applications. Then you have your application server, and then you have all the dependencies, the entities, the third-party Maven dependencies as well from this application. So this is the one that you are trying to develop, maintain, and most importantly, to have it online on your servers, both on the developer side and also on the operation side. So basically, this is the normal picture of a normal company that is not into microservices as for the moment. So you have your applications right here, your entire application that consists in a big, well, it is called monolithic. You have always your programmers team, your business analysts, your project managers, the QA people, also the security and compliance, the DBA, and of course you have the operations team that is always trying to push, and trying to push, well, not to deliver software is can complain and it can give troubles to them. So that's the old picture, right? But the new picture should be like this when working with microservices and microservice architectures. You have the two-piece team is called, because you build it and then you own it. You do not just build it and then deliver it to the operations, and you don't care anymore about that. So basically, you will start developing, services with specific teams. As you can see here, you have the developers, and also you can say a project manager. You have always a project manager, the developers, and this guy also need architects and also QA, and so forth, so on, right? So then you will need to strangle the monolithic itself. So this will be like a high level overview of a monolithic application, which I know you guys can do the reference with all the software that you guys work day to day. If you are not into microservices yet, that you have, your user interface, your users actually enable, well, where your users interact with your software. So then, maybe here's the introduction to the entire system, and then the entire system is using a database to save the data. So you need to strangle the monolithic, right? And in order to do so, you will need to start to develop new microservices, and you will need to start to do, like, for example, you have a monolithic application of a website that saves, like, let's say, resumes for the people. So in this case, you can develop a microservice that is, for example, the profile microservice, on where you will be saving all the profile information about the job seekers, and then you will be removing that microservice or that service for the job seekers, the profile itself. From the entire application, you could start doing and developing more microservices as well for them. For example, here you have the job profile. He will have you, for example, the jobs themselves that you're pointing into the actual application, and all of these are using, for example, another type of database. So you will not be depending on a big and entire database itself. You will be working with small databases, or, well, at least isolated databases that you can also take advantage of the new technologies as NoSQL, and developing your actual microservices to start using NoSQL or SQL. But whatever the thing you are using, you can start developing those, and therefore you will be strangling the monolithic onto a point that you will have like kind of this. And since you are developing and migrating to microservices, all your traffic is still going to the monolithic, but you will need to start redirecting traffic to the new services, and start, for example, develop those microservices and then add those endpoints as we saw before, API requests or API HTTP to the actual software. So the software, once the user enters, instead of going here, it will go to these microservices. And also then you can add another interface to maybe another microservices. And at the end of the project itself, migrating to microservices, you will have your monolithic less and less, small and small. And we will see the actual advantages of having this, because you maybe are asking, why should I try to do that, right? So then you have this one. So I also like this cartoon as well. On a cool developer is presenting the monolithic. Right, here's the monolithic. uh, let's all give it for the monolithic who is about to retire. I will also take this opportunity to proudly present the microservices. And then comes the guy to developer and, hey, give me five, and talk to my API gateway, as all the microservices need APIs in order to communicate between each other. And then you can see that microservices is having issues with another microservices about the databases. And then you will see that you need to actually orchestrate them first, the microservices itself. So yeah, you will might need some orchestration first. So yeah, we will be talking about the orchestration later on as well. So talking about the microservices principles and characteristic, they are deployment independence. They have deployment independence. So meaning that updates to an individual microservices have no negative impact to any of the components of the system, and they are optimized for the replacement. A lot of companies I have seen that are trying to migrate to microservices because this is, like the first or the main goal that they have, the main concern as well that they have on the production services on monolithic that they currently have. Because let's say, for example, you are updating the front end of a website, then once you deploy that change, no one knows how, but the backend itself is getting messed up with that update, which supposedly have nothing to do with it. So working with microservices, they once you deploy the microservices and update it, it only works within the microservice itself, so you will never be affecting any other microservices, or well, at least on a code basis, right? Because microservices can also depend from each other, and that's another topic as well. So second one will be organized around business capabilities, right? So business project owners and product managers can develop their microservices within the business capabilities that they need. As for example, the one I just mentioned about you developing a microservice about just the job seekers or job profiles, or yeah, that will be something to base on. Also, the third one is products. You are developing products, not projects, and that's also a benefit, because when working with monolithics, you're developing projects. So for example, we are adding this new module to the entire application, and that will take, like, for example, 1 to 3 months, right? So when working with microservices, you are developing products. So instead of developing or having a deadline of 3 to 4 months, you will have like deadlines of 1 to 2 weeks, because you're developing the entire module in a way of microservices. And you can do the actual example I have told you before, from working with the job seekers, working with the modules. Instead of working on an entire module of profile, you can work that module of the profile doing microservices, or one microservice will show the picture, the other microservice will query the data from, from a database, and another microservice will point, for example, the salary of the actual job seeker that is looking for, and so on. Also, another point is API focus. The entire microservice ecosystem and architectures are based on API calls. So they all communicate and they all send and receive messages and data by using API, as we saw on the comic before, that they need API to communicate. So also you have a smart endpoints and dump pipes, meaning that the entire endpoints that you define for your microservices will be always be, they should be like really describe what the actual microservice does. So that's also another goal and another principle of how to develop microservices. And another one is decentralized governance, which is kind of self-explanatory. And also you have decentralized data management, which is also another good point and a strong point when trying to migrate to microservices, as you're managing all your data into different, well, you can say into different servers. You can say if you're managing, your containers, well, your data and from each microservice differently. So you can have, for example, instead of having one big MySQL database, you can have four SQL MySQL database differently with specific data for it. And also is infrastructure automation, which it is included as infrastructure as code. And this what is also a nice point for microservices, that they allow us to have infrastructure automation and be really elastic, and they can grow and shrink whenever they need. And that's another important thing working with container. And this is also provided by the orchestration of the microservices, in this case using container orchestration. And also is designed for failure, right? Because as we saw before on the point of infrastructure automation, if a container or a microservice die, you can just respawn it right away, and there will be no issues at all. As that's the main goal of having microservices, that you will treat your code and your actual infrastructure as cattle instead of pets. And that's also an important mindset to work and also to be aware of when working with microservices itself. So also they have the evolutionary design, that they will always be evolving your microservices. So for example, you will be having a microservice right now, and maybe in 2 or 3 months you will be updating those microservices into a powerful, or we can say into a powerful language or a few implement on the actual microservice. So that's also a nice characteristic and principle as well from the microservices. So, well, at the end of the day, you will have that the actual microservices is really good, but your actual code isn't. So, I like also this cartoon that say that your code is so ugly, but you will always say that it's work in progress.
Andres,
So now talking about
your
the,
video for a second. I think it's
of course.
backwards.
So,
Give
well,
me
at the
one
end of the
moment.
day, you will have the actual microservices is really good, but your actual code isn't. You will always say
Okay,
that.
I can see the video now. Keep going. Let's see if it works now.
So now
Thank you.
sorry, I couldn't hear that.
Go ahead and start. Keep the presentation going. It's just that the video, for some reason, the presentation cut out, but it's showing up again. So you can keep going. Thanks.
Okay, perfect. So, yep, talking about the journey to cloud native. Cloud native itself is the name of a particular approach to design, build, and run applications based on infrastructure as a service, combined with new operations tool and services like continuous integration, container engines, and orchestrator. The overall objective is this: to improve the speed, scalability, and finally margin. So that's also talking, when you're talking about containers, you're always trying to move to, the journey to the cloud native. You want to have your entire company as a cloud native company. And according to the Cloud Native Computing Foundation in CNCF, a cloud native strategy is about the scale and resilience. Distributed system capable of scaling to den of thousands of self-healing multi-tenant nodes. So that's what the CNCF says. And what exactly is CNCF? This is really important to be aware of, and to have in mind when working with the entire microservice ecosystem. And well, Cloud Native Computing Foundation is an open source software foundation that making cloud native computing sustainable. Cloud Native uses an open source software stack to deploy applications as microservices, packaging each part into its own container and dynamically orchestrating those containers to optimize resource utilization. Cloud native technologies enable software developers to build great product faster. So basically, what Cloud Native Computing Foundation does is like a company that embrace a lot of new technologies that enable the microservices working in the best possible way. And Yeah, that's basically what they actually do, and they actually own, you can say, own the Kubernetes project itself, as and is also the biggest one that they have. And then you will have a lot of projects that are already, and well, also adding maybe month to month to the Cloud Native Computing Foundation. And for that one, I have these URLs right here on where we can see the actual, well, they call it landscape of all the projects that the Cloud Native Foundation has on their on them, and you can actually implement all those services or projects into your container orchestration of all your microservices. Well, somehow this is not loading, and well, you can guys then later see the actual presentation and see the URLs. I will be sending this presentation as well. So let me close this. So then we have the transition to cloud native, and this is a picture that it has been in around for a couple of years now, on where, well, mostly Red Hat, the ones that are trying to point this. Well, it's actually on the Cosire DevOps and the cloud native journey. So you first need to reorganize your DevOps strategy, your mindset itself. You have to do your DevOps team and so forth. Then you will evolve, because they are using that word evolve, to all server on demand elastic infrastructure as code. Infrastructure as code, you can see this little worm. One, then you will use automation by using Puppet, Chef, Ansible, or any other configuration management. And well, you can also use Kubernetes as well. Once you are using those tools, or at least you are in here, you then need to evolve to a CI and continuous integration and continuous delivery and deployment pipeline. Once you have that pipeline, is because that pipeline will be already consuming all of these services, or well, it will be implemented when using all of these three. And then you will have, you will be a monkey, and then you will have your advanced deployment techniques, on where you will be deploying your application by using the pipelines, either by canary deployment, blue and green deployments, or maybe A/B testing as well, or maybe other technique that you are doing in order to develop your code faster. And the final step is to convert into a unicorn, right? Which is the Silicon Valley.com startups, like for example Netflix, Uber, and other companies that are already using microservices, because the final journey is use microservices. When using microservices, you need to at least have all of these already in place. You can maybe skip one of those, but the best practice is to have all of these in place in order to use microservices as they were supposed to be used. So this is the same picture, but maybe more formal, on where you have the digital Darwinism, as also how they call it. And this, the developer's journey as well, on you always reorganize DevOps, and then you evolve into, you become a flying elephant by using microservices. I also like this one because it's more formal, you can say, and you can see the actual picture of Darwin, of the evolution itself. So talking about also of the unit of deployment, we went from having physical servers to having virtual machines, and then we evolved to have containers. And on the big at the end of the evolution is also functions, which is also another topic that is evolving and developing really fast on the actual ecosystem of well, the entire IT industry. So this is another comic that I also like, because since we are jumping right now to containers, the number one excuse right now for the programmers will be my Docker containers are building, and they are just playing. Meanwhile, the Docker containers are building, and we will show them. I will show this later on. So you have the cloud native dev and ops maturity model, which specify exactly how is the actual maturity of the actual software development life cycle, on when the current state when working with monolithic, or yeah, the current state of the actual, or the entire IT infrastructure and ecosystem, is that you build artifacts, either code, configs, and credentials, and then you have your build toolings, right? You have your code repository, and then you have your continuous integration and delivery pipeline. and then you actually deploy. And well, the actual final product is, a runtime, a binary that then you will be deploying to a bare metal server or virtual machine in that case, maybe on a data center that you have, or even on AWS, or even on the cloud, sorry, not just AWS. And but actually you need speed, right? You need to add speed to your software delivery life cycle in order to update and have well, in order to deliver products to your end users. So with the cloud native, with DevOps itself, you will have now this. You will be building artifacts. Always will be building artifacts, but you will add the container images manifest, the container runtime manifest, and also the service mesh manifest. And these three are added to the already existing code and configuring credits. So now you will also have your building tools, hosted on a code repository, and then you will have also your CI/CD pipeline. But instead of just developing the binary, you will be developing or deploying or delivering, you can say, container into a container registry, and well, you will be saving all your Docker images, all your container images, and then you will have your container that will be running as a microservice, and using a container orchestration plus a service mesh, instead of having them running directly your binary into a virtual machine or a bare metal, because the container orchestration will be the one sending and deploying and running the actual containers that you already developed and are already hosted on a container registry. So that's basically the cloud native itself with DevOps. And you know what? This is another picture that I like, because it's the enterprise journey to the cloud, right? So, and this is a project I worked before, and some of the UI designers did this for me. So basically, you have the legacy software right here that you're trying to, you can say, well, you're trying to handle in order to have it directly to the cloud, right? So you will have the DBAs, the senior developers, the project managers already dead because the deadlines are already messed up. You will have the cloud architects and also the sysadmin trying to tangle the actual dragon of your legacy. Meanwhile, the startups that they don't have any software already, that because they are startups, they can just run those commands, and bye bye. The cloud native application is already flying, and it's easy to it's easy to manage, right? So this is a really nice, and it actually gets the picture of trying to get the enterprise journey to the cloud. So now we jump to the specific topic, and one of the hottest topics right now, which are containers. And well, containers, you will imagine a container from like this, and it's actually the same thing, because it is a container. You will be transporting and shipping all your entire goods in here, and they will be protected, and they will be always be the same as is this container. Maybe the color will change as well, but at the end of the day, you have your goods delivered directly to from point A to point B. In this case, from point A being the local developer computer, and then point B being the production server running, maybe on a data center on the other side of the world. So when containers in the picture, new things arrive, right? Because before that, and we are using here DevOps, because DevOps itself is trying to DevOps itself, the mindset itself is to work with containers. Therefore, when working microservices, you will use containers. So before, the developers will always say it works on my machine once the actual code was deployed into production, right? And the sysadmin was really mad. And then after DevOps, now the developers are saying it works on my container, and the sysadmin will be really pissed off because every time it works on a container. So this is also a great picture. So what exactly containers are? So actually it depends on who you ask, because you have the sysadmin and operations team that says that they are sandboxed applications processes on a shared Linux OS kernel, or they also say that they are simply lighter and denser than virtual machines. And they also will say that they are portable across different environments. But if you ask the developers, they will say they are package my application and all of its dependencies, which is also true, and one of the main goals of the actual developing using containers, that they package your application. And we will be talking as well further about that. for this later on. And they also deploy to any environment in seconds and enable continuous integration and continuous delivery. And finally, developers will also say that they are easily accessed and share containerized components. So basically, containers package applications with dependencies and isolate the runtime. That's basically, if you want like a definition of container, that's basically what a container is and does. So they are easy to deploy and portable across systems. They are created from immutable layered images because, well, I will explain that later as well. And they are isolated from a host operating system. So this is done through, control groups, C groups, talking about Linux environments, kernel namespaces, CI Linux, SVR, and IP tables to do the actual networking of the containers. And well, basically, this is all enabling and thanks to Docker itself, which is the container engine. Well, you will say that is the de facto container engine as for the moment, because maybe there are others in the market, but to be honest, they are not quite used to like any. The market share is totally to Docker. So basically, you can see the images right here. You have always your server, then you have this host operating system, which can be a Linux system or a Windows system, because you can also run Docker on Windows. And then you will have your container that only has the application itself that you have developed and the libraries that it needs to run this application. So you can have multiples container running on a host well, on a server itself. So the main difference between a virtual machine is this one. Containers provide a high density and efficiency at the expense of isolation. So that's basically one of the key points of containers, because you will have the physical server that takes around 27 hours to provision, because we're talking about a physical server, right? You need to establish racks, hard disk, install the operation system, and at the end, you will have the server, the operation system. You need to also have a hypervisor enabled on that server, and then you will need to launch the virtual machine, right? That will have the guest operation system, the libraries, and the application. And approximately you can have at least 10 virtual machines per server, and that's a lot of space consumed by the guest operation system and resources as well from the hypervisor. So maybe you will be jumping then to virtual machines, right? Using virtual machines instead of physical servers. But that it still takes 12 minutes. And at the end of the day, you will also have this one here that you have a limit for the virtual machines. But when you are working with containers themselves, the main difference between the containers and physical server that you can compare with virtual machines is that the container, they only have the host OS, and then once you have the host OS, you don't need a hypervisor, as Docker itself or the container engine that you're using is the application that enables this. And you will always have only your container, your applications, and your libraries, and you can have multiple containers, at least 100 per server, whereas on the same server you can only have 10 per server. And at the end is the same application that you can replicate 100 and here just 10. So your resilience and high availability is really key as compared with the physical server or virtual machine. And they are spawned in less. Well, this will also depend on the actual container that you're working, but normally, and the average for a container is 10 seconds in order to spawn correctly and well, run the application. So that's basically the main difference. So yeah, this is me trying to move a container, from point A to point B. That's not efficient, and if you do that, you maybe you deliver the application, but that's not the way you should actually handle your containers. You can see here a lot of troubles trying to move that container on an actual boat, a little small boat. And then you can also have this type of mess on your containers. Working with containers, you can have, I have seen a lot of mess on, when at least when you're working on a developer or maybe on a production without using container orchestration. And this can also happen, right? You have already your maybe your big ship that is trying to run your containers from point A to point B, or trying to handle the containers, but something can happen that your ship can sink, or anything. So introducing now is container orchestration, right? You need to have your containers in a very or well, you need to have your containers really tied up, and also align with your actual capabilities of the business. So as you can see here, we have container orchestration when you need to to be handling your containers like that. You can and I will also be doing some, well, I will be doing some example as well. As for example, you can see here as the container orchestration engine that is trying to pull the containers from point A to point B to the ships, and here is where all the containers are saved. And in this case, you can do the reference as doing these containers being, the version of your application that are already saved. And you keep saving and saving the application version and releases, and you can actually separate them. The applications themselves, you can separate in, for example, namespace or also names itself, right? So that's the actual need of a container orchestration, because without using a container orchestration, your containers will not be good, and you can have a lot of troubles when running containers on a production workloads or scales without a container orchestration. And I will be talking about what exactly container orchestration does. But just to start, we have these container orchestration on the market that are one of the hottest as for the moment, but the de facto as for the moment. And everything is moving towards this little guy right here called Kubernetes. And you can also see Docker Swarm, which was introduced by Docker itself, the Docker company that developed and released Docker. You have also a Mesos, you have also AWS ECS. You can also have a Red Hat OpenShift, which also runs on the Kubernetes engine, and add some new layers as well. Well, some new updates from ECS that they will not moving towards Kubernetes. They have their own, like you can say, engine, their orchestration engine, but now everyone is moving to Kubernetes, and we will see why. You you also have Rancher as well, which is one another open source that is really powerful. And also you have HashiCorp normal container orchestration. So talking about Kubernetes and why to choose Kubernetes, Kubernetes is specifically designed to bring developers and operations team together. And you can see this little picture right here. And Kubernetes in a high level component architecture. But before entering here, and let me just explain in a briefly words what Kubernetes does and allows to, well, in to developers and operations engineers and also DevOps engineers, being in the middle. Kubernetes allows you to manage, that's the main word that you have be focused on, manage your containers in a very safe fashion way, in a very organized way, where you will be deploying your containers into different servers, and well, multiple servers, and those containers will be always respawn if they are, like for example, your application crash. Kubernetes will be automatically respawning those containers right away. And you can actually enable notifications and everything, a logging monitoring system to have all that information bringing to you on live time. So that's what basically Kubernetes, and not just Kubernetes, but all the container orchestration that I showed you before does. The main difference is that they have maybe some different functionalities, and and therefore they also have different terms for dealing with the same thing. So, for example, the scheduling of your actual containers on specific nodes, so you can do that also by running a Kubernetes or a container orchestration, because you will be managing your entire containers from a single point, from a single screen or a single command, on where you will have access to the entire ecosystem. And yeah, I will be showing you as well some on the presentation. So on a high level component architecture, you have, talking about Kubernetes, you have a lot of components that work together, and at the end, they provide you, one of the best resilience tools that you have to manage in your containers. You will also, this is also work on an architecture of a master and a slave, right? So you have your master Kubernetes node, and then you have the node pool, the node themselves, right? And you have, the networking, the kubectl, and as we saw here are the servers, where in this example we have three servers, where is a virtual machine, a virtual machine running on a data center, or maybe on any of the cloud providers. You will always have your hardware, your operation system, your container runtime, in this case Docker, and then you just add the kubelet, which is the master, that's the one that schedules and deploys the entire the entire containers, right? And you are managed by a user, a single user, which can be a developer or actually anyone that needs to develop and to deploy containers on on a production or a developing stage. So the user can access it via the API server or also use the API server using a command line interface or using a user interface on a web browser. So this is also a nice picture of how exactly it works on a really, really detailed way. So you have, the cloud providers right here, Google, AWS, and Alibaba Cloud in this case. You have, a connection itself. You have Ansible that is deploying as well to Kubernetes your applications, and you start on the Git zone on where your actual developers are deploying, not deploying, the developing the code. You are merging, the review, the testing itself, the code, and then from there they go to the actual, as we saw in the pictures before, on the container registry. And also a very important thing to mention about containers is the container registry, which is basically the same as having your code in a repository, but in this case of having just code, you will just have docker containers or images in this case on the registry. So in there, as you can see, Ansible is trying to using some modules from Kubernetes, moving those to the actual whales of Docker, the image of Docker. And then you can see the Docker running your containers. In this case, is running three, one, and one. And here is the part of Kubernetes itself. And also, you will see monitoring as well of some syncing Docker instances. And yeah, that's a really cool picture to actually get into the actual architecture or how actually Kubernetes does the job. And this is another high overview of how container orchestration work. I will not be getting much into detail, and in this case, is for the Rancher server. But as I mentioned it before, all the container orchestration does the same job. Orchestrate your containers. So it's basically the same for mostly all. So you have the Rancher server itself, or in this case, the Kubernetes servers, and then you actually control it by the web UI, container or REST API, sorry, CLI or REST API, and then you just deploy to the Git repository or Docker repository. Well, you have your images, and then you deploy those images to the actual servers themselves. And you can see that it's being done by, in this case, Rancher used this Cattle engine, on where Kubernetes use Kubernetes engine itself. And then, yeah, you have all your data deployed automatically, and you have also some persistent storage for containers, which is also a thing. And yeah, that will be a high level overview of how you actually orchestrate your containers using a orchestrator. So there is also a big thing that is on the market as well, is that the people is offering Kubernetes as a service, because it sounds like a lot of Java, and it actually is, having a new entire cluster and new servers and a new software that you need to learn in order to deploy your Kubernetes applications. And some people say that they are moving to containers, but they are actually, instead of removing servers, they are just adding more servers to manage. And the operations teams or the resilience guy will always be complaining about this. So that's why this Kubernetes as a service is born, and a lot of major cloud providers are offering it. So what this is basically achieves is that you will not be needing to take care about the provision of the entire cluster. You need to provision the master, then you need to provision the nodes, the slave nodes, and then do some configurations with the networking and everything. So this is all delivered right away with Kubernetes as a service. We have big challenges here from Platform 9. We have the recently announced Amazon EKS, which also deploys an entire Kubernetes for you. You also have the Google Container Engine, which I will be demonstrating you guys later, and also you have Azure itself, and also, of course, Oracle. And there is a big competition within it, and you should try the one that best suits your needs, because maybe one is not for you, but another it is for you. Something that point out is that this type of service is are not recommended also for everyone, because if you need really complex or really detailed infrastructure or configurations, you should actually deploy your Kubernetes, alone, because these are really self-managed Kubernetes clusters, so you don't have full control of the entire environment. So yeah, I know it's kind of boring. So if you guys want to, yeah, you can do it. So now I'll be showing you some demo about how, deploying these microservices in form of containers, deploying it into Google Cluster Engine. And here you can see a picture of me trying to do this right now. So hopefully everything will work as expected. I don't know if you guys have any questions as for the moment. So yeah, I know it's kind
Keep
of
going,
boring. So if
Andres.
you guys want to, yeah, you can do it. So now I'll be showing you
No,
some
no,
demo
no
about how
questions for the moment.
deploying
Keep going.
these microservices in form of containers,
Can you
doing
hear me?
deploying it into yeah, perfect. I will continue then. Here you can see a
Good.
picture of me trying to do it. So yeah, I will be showing you, as I told you, we have, I will be deploying this node application to, a normal node application. Then I will be deploying it into a Docker container running on my local machine, and then I will try to deploy it into the Google Kubernetes engine. Uh, so basically, when you guys that are, we are programmers. I'm not, but I like to think so. We have this server, this Node.js basic application, and we are requesting, HTTP, and we will request, the URL, and then we will write this, and then a simple response that it will say, "Hey, hello from," and then we will be sending this environment variable, which is also really important when working with microservices and in containers themselves, right? Because you can have the same application, for example, the same microservice used in different applications, or in different methods, and this is done, by using environment variables. And this is also important and helpful when working with databases and, information that should be kept secret and not needs, it doesn't need to, like, to you don't need to burn the code itself on the actual code, so it actually really configurable and configurable with variables. So once we have this hello from, and you catch the actual Node.js application, catch the environment called pov name, then we will have, create a server and listen on this specific port. So basically, if we run this application, hopefully it will run. Well, first we will send the actual variable value. So for example, hello from hello, it will say, right? Null server JS. So we have it already on port 8080. So if we run it, we will be able, to go to localhost port 8080 and see, right, the application that is saying hello from hello, as this is the environment variable that we pass through, the command line. And this is really important, because this environment variable, I will be the one that environment sorry, that variable, I will be sending some parameters from the Kubernetes, and also from, yeah, Kubernetes will be sending some information to that specific variable, so it can show exactly something really useful. So in this case, we have the server. So in order to convert this into a Docker file, the only thing we need to do is to actually work with a Docker file itself, which is the actual file that defines how the container itself will run. So in here, you can see like the from, and the from is just basically states on which actual Docker image will run. So these are already predefining official images that are already is a container that has already Node.js installed with this specific version, right? So you can have very basically everything from here, from Node.js to Python to Java to actually every language that you can imagine, and that has already not hasn't to be official, but it has already a container image. Then you actually want to expose some ports so the application can be reached. In this case, we will be exposing the port 80 and the 443, and then we will just copy in the server GS, to the local path, to the root path. And in this case, as we are on the folder, we will be copying this one into the container. So in here is when you actually copy the entire application that you are developing into the container. and then the command will be like no server JS. So as soon as you run the container, it will run that command, and therefore it will do the same that as we just did right here. So let's try to cancel this. So in order to have this as a Docker with images, as I told you before, and that works with a Docker image repository, which can be a public repository or can be a private one. When working with microservices and container orchestration and developing, you always need to use a private container engine for the registry. So there are also a lot of providers. So in case you are using AWS, you can use ECR on where you will be developing, well, you will be deploying or saving all your containers. You can also have, in this case, I will be using the Google Cloud Engine. So first, let's build the image. So you can just do a Docker and then build the image. You select that the Docker file is right here. You can select maybe that the Docker file is right here, and you put Docker file. But since I'm running into the same folder, I just need to build this, and then I will need to tag this image. And the tag itself is also very important, as I mentioned before, when working with versions. When you have your Dockers, you will be start to developing a lot of new versions. So, for example, application version 1, application version 2, and that specific version is the one that you will be doing, the orchestration and deploying to your actual servers. And also deployment techniques can be applied to this by using the specific tags. So in this case, I could tag this image hello demo. So for example, if I hit that, it will start building the actual container and the image itself, which then I can just run and then I can just push. So as you can see, it will step one from Node.js, and as we saw on the presentation, Docker works with layered images. So meaning that every container that you have will be built between images itself. So for example, right now he's using Node.js, right? So I have already this one in my actual repository, on my local repository. And if I didn't have it goes to the internet and download this right away. And then, since I add this new, it adds a new image to the actual image that we had, and the same for the other steps. So as you can see, we already tagged the image as hello demo latest. So if we want Docker images, which is also a command to list all the images that you have, I have some few right here, as you can see. So you can see that we have Docker images, doc hello demo tag latest. So as you can see, since I didn't change anything and I already built the image, I already had the hello demo application with the tag latest. And also you can see some others that don't have any tags, but you can just tag them right away. But since we are using this one, I will just run the container right now to see if it actually works. Hopefully it works. Docker run, and then we need to specify exactly which port this Docker container will run, because Docker engine has, like, it has an entire engine that I'm running right now on my computer, and also some network spaces and everything that enables that you can access the actual endpoints of the containers. So also very important is that when working with containers is that you use a lot of the ports that you define on your container. So for example, in here we're Docker run, and then we'll set the label or tag P, the parameter P, which means ports. And then you will have, the port on where you want to run this locally on your computer, and the actual on where we'll be running on the container itself. And then we just say, hey, I want this image that I already built with the tag latest. So let's see if that works. So normally this will work, and I don't know why, but my computer is gets stuck in here. So, but if I go to localhost 8080, I will receive this refuse to connect. But if I go to directly to the localhost 80, on which I specify on the actual port on my Docker, you will see that the application is already running, and you can see a hello from undefined, because I didn't send any valuable values as I did before in here, right? I didn't specify the value for this. So the application itself is waiting for that. And as you can see, it's running on port 80, but the container is running on port 8080. But on my local machine is running on just on port 80. And you can see that the request I received from here. So if I try to cancel, it won't work. So yeah, that's exactly how you migrate, or you can, migrate, yeah, a simple application Node.js application to a container. So right now, your very same application that we run before with Node is now running with Docker. So now let's try to to deploy it to Google Kubernetes engine. So I basically have already a Google's Kubernetes engine right here, which is actually one of my favorites as from at the moment. I like to think that I'm really a AWS guy, but to be honest, this one is really, really better that AWS have, and is as I told you before, a self-managed Kubernetes engine on which you just create your cluster and you say how much the nodes you want, and then you can actually just deploy your application once you have the cluster. Another great thing that you don't need to access the web interface or anything to Kubernetes itself. You can just access it right directly from here. You can see workloads, well, the deployments themselves, the services, and other stuff that is really useful. So basically, when you are running with Kubernetes, you need to define some. I will be showing you need to define some objects, right? Kubernetes objects in YAM file or JSON file if you want. So basically, what we want right now is that we already have this Docker file in here. Well, something that we are missing right now is that we have our Docker container running, as you can see right now. If we run Docker PS, you will see the containers that are currently running on our local machine, and you can see that here's the container ID. You can have this very same thing will happen on all the nodes of Kubernetes or any other server that you're running. You have the container ID, the image name, and then the command that was executed within the actual Docker, which is this one, cmd node server. And then the creation time, the status, and the ports that have been already established within the actual Docker. And then you can actually use some names, and this focused pointers is a random name that Docker assigns when you don't specify any Docker name to your container. So once you have this locally, you need to ship it to production servers. Hey, the test passed or whatever, and you need to push it to production. So you need to, as I told you, you need to use a container registry for that. And since we are using Kubernetes on Google Cloud, we will be using Google Cloud Container Registry, which is, as you can see, just this here. And when you have your images, in this case, it's called Hello Node, and then you have all the versions that you want. And as you can see, I was trying to test it up some hour ago, and you will have multiple versions right here, and you just have the tag. And at the very end, well, if you want, guys, let's try to push this thing. But first, every provider has its own rules in order to push their actual images. In this case, Google, you just need to be authenticated with Google, and then you can just do a Docker push, and then the image name. In this case, the image name is self-explanatory, and then Google automatically catches this subdomain, and it understands that it's an image that you're trying to deploy. So it's actually really useful and really easy to deploy. So we will be deploying the late. You can see now. Let's try to well, yeah, let's try to deploy this one, the latest one. So if you don't specify a tag like this, it will always push your latest. So once you run Docker push, you will see that push refers to a repository, right? And then you will see that layer exists because, to be honest, this was the one that I built later and not the one I just built right now, but it will be the same. So it detects that the image already exists, and as you can see, there are a lot of images, as Docker is based on layer images. So once you have your images it detects that the images are the same. It just push it directly, and in here you will see your actual Docker images already running, or were not running, but already saved into the container registry. And you can see that it actually detects that I just pushed the same very image, but at least it detects that it was uploaded just now. So once you have that, you then can do whatever the thing you want on production servers. And in this case, when you use a container orchestration like Kubernetes, you need to define all your objects, because they are called objects, into YAM files or even JSON files. So in here you will have a deployment type on which we are naming the deployment as a client one. And then we want to have, this is something important, that exactly, hey, how many pods you want, and I want two. So Kubernetes is clever enough to detect that you want two instances or two containers of the very same application, and it will spawn those two containers, or in this case pods, because Kubernetes, instead of calling them containers, are called pods. As you know, you can, this is another topic, that you can have multiple containers running on a pod, but normally you will have only one. So it says, hey, this guy wants two pods, so I will schedule those two pods to random. Since I didn't specify it as well, I will launch those two pods into a specific nodes. And since you guys saw already, I have 6 nodes on this cluster. So yeah, you will have your naming convention, then you have the version as well. This is just, a tag that is being used on Kubernetes, and it's really helpful when you're trying to deploy a new version, for example. So don't forget that this is a deployment, and then you have your container. Okay, what container do you want me to launch on this pod? And you say, okay, first name the container client one, and then you will be using this image. For example, the image that I just launched, right? The hello node test, but in this case, we're not using test label, we are using latest. So, since we are using Google Kubernetes Engine, it's also clever enough to detect that this is from a private container repository. So it already does its job, and authenticates and pulls the image directly. Because if you try to pull this image another computer which is not authenticated or has the permission to access this image, you will be receiving an error message that it says forbidden, or actually it doesn't exist. Then you have your container port as well. Okay, this pod will run on this container, and we already saw that. And then this is something important as well, that you can send environment variables, in this case the pod name. So remember, we were running the application in here. Okay, run in here. So we want to have, instead of hello from, and in here we will be displaying the actual name of the pod on where the container or pod is running. And as you can see, that it's actually gets this value from the metadata dot name from Kubernetes. So Kubernetes will automatically get this variable and send it to the actual container as a pod name environment variable, and our application we read that automatically. This is really important, because in here you can start using, this is something called from Kubernetes secrets, and where you can start using, all for example, credentials, databases access, or whatever the thing you want, and send it directly into the pod itself. And then, as you can see, I have another deployment on where I have client two. And in this case, as you can see, we're using the same container. And what I'm trying to prove right here is that we can use the same application, but it will be delivered by using, like, for example, you will be able to access client one and client two, and those should be different, in this case client or application, but at the very end of the day, it's the same application running, but using a different pod name, since this will be a different pod name. Okay, once you have the deployment, you deploy that, and then you create a service, which is also just define exactly how will you be accessing, the actual deployment that you just did. So you want on the port 80 to go to port 80, and the selector itself will be client one. So this service will be also clever enough to select all the pods that have the actual name. And since we have two, those two pods will be automatically saved into the service. And we also are deploying client one and client two, and you can do a lot of things with services, but this is a basic demonstration. So once you have your service, if you specify like a load balancer, Kubernetes Google Cloud Engine will also deploy and create a load balancer directly for you, and you can then just access that IP or DNS record, and you will be able to access those pods. But since we are using something more complex and trying to achieve the same thing that I'm telling you about the actual clients, so then you need to also create an ingress on where you will be creating, if the host is this one, then you move there in the path is, the path is clean, you please respond with the client one service, and the client one service will go to the pods that are on the client one, and very same for the client two. So now you just need to, deploy these objects that you develop, and also you can create them as well on the user interface. So basically, what you will do, as you can see, I have here the objects. So basically, you just do a kubectl, which is kube control as well, or kubectl, as some people say. And this is basically the CLI that enables to manage the entire cluster that you have, and you need to connect before, right? You need to, once you create your cluster, or you create your cluster, you need to run some commands in order to connect in this kubectl to actually connect to the cluster. So for example, if I run kubectl get nodes, I will be getting all the nodes that are presented on the master, oh, sorry, on the cluster. And you can see all the nodes that are already status ready, and you know the version of the Google of the Kubernetes itself, and you know how the age itself. So let's just apply those, and you can just do qct apply from a file, and then you just say client deployment, right? Oh, this is something that happens too often to me. qctl. As you can see, I already have those two, but you know, and it's also is clever enough to detect that no change has been made. So it just say, hey, I actually did something, but it didn't change. So let's try then to do, you know, because I didn't save this. So now it was already on test, if I recall. So as you can see now, it configured it because it before it was using the test tag, which it was a different image, but now we will be using, you know, the latest one. And let me see, once you have the deployment, then you will need to actually do the service, to deploy the service, you know, the very same. You just apply and then the service that you want. And as you can see, I already have it created, so it's unchanged. And then finally I will have an ingress, which is the one that enables you to actually access the actual services. So as always, is also say unchanged. And as you can see here, if we go here to the cluster, we will see that we have on workloads on where you can just see the actual containers. And yeah, somehow it is, I had this error before the presentation, and I didn't have the time to correct it. But as you can see, you know, the both endpoints or both deployments that we created, as you can see, is a deployment have been created. And here you can see a lot of information. You know, we are receiving this error, which, you know, you need to troubleshoot. And you here you can see the actual the pods that were created. And if you go to a pod, you know, you will see exactly on which node is running. You can see the logs, and of course you can see that is image pulled back off, and of course you will need to troubleshoot. So that being said, you know, I will not be able to actually go to a specific IP and show the actual thing that we saw on the local host. And but you know, it gets the picture. And also here you have the services that we created. So we have you have some endpoints as well, but you know, these are private IPs and internal to the cluster, so you will not be able to access it unless you have a proxy or something. And also in here you have the client ingress, right? So if you supposedly go to here, you know, first of all, that record should exist, right? Either on your etc host or on a public zone, that record should exist, and it's pointing to the actual service of the ingress that you just created. And in here you can also see that services are also shown on the name, because also Kubernetes use like namespace to enable, you know, resilience and security. So you have here the clients, and also let's see the clients that we created first. And you have also the serving post that, as I told you, with the metadata, you're saying all the posts that have the client to attached to this service. And yeah, unlucky for me and for everyone, you know, this isn't working right now. But yeah, that's basically what exactly I was trying to accomplish right now. I should have looked into it with more detail and time in order to enable it. But yeah, that's basically the demo I was trying to show you guys. So let me just finish in this by doing, you know, to questions and answers.
That was an awesome presentation, Andres. Great, great. Thank you very much.
Hey, thanks.